Alright, hi everyone. Someone reminded me that we didn't wrap up classwork 9 together before the break. So let's go ahead and, I think I checked most people's answers on these before you left and they all looked good. But if you want to check your answers, the top part, I'm on page 81, by the way. So continuing with classwork 9, just wrapping up the last page. Sorry, I know this is not the most sophisticated setup. Okay, so let's clarify some terminology and kind of link some ideas together here. So we started out by using a categorical variable to predict a continuous variable. So remember, categorical meaning that it's categories or groups, and continuous meaning that it's a range of values. So think back to the example we used where we used height category. So this is our categorical variable. We were talking about people in the short half of the class versus the tall half. So short versus tall to predict thumb length. And thumb length was some number, right? The value of how long their thumb is. We're going to be transitioning from using categorical variables to predict continuous variables to using a continuous variable to predict another continuous variable. So in other words, using some value in a range of numbers to predict some value in a range of numbers versus using groups to predict the number. Okay, so in this case, where we're talking about using height category, short versus tall, to predict someone's thumb length, how many variables are involved in this case? So here, this is a very common mistake. People will say that the variables are short and tall. These are actually the levels of this variable. So this variable, height category, is one, and thumb length is another. So how many variables involved here are two. How about in this case, where we're using a continuous variable? So in this case, we would use somebody's actual height, not are they short or are they tall, but actually how tall are they? How many inches tall are they? So using how tall they are in inches to predict how long their thumb length is. So in this case, we are still using height, that's one variable, to predict thumb length, our second variable. So in this case, also two. Okay, so when we're using height category to predict thumb length, what is the predictor variable or the independent variable? And I have some other, AKA IV or factor. These are other names we use just to talk about the independent variable. So in this case, what is the thing that we think is influencing or is helping us to predict something else? What is helping us to predict something else? Okay. So in this case, we're using height category to predict thumb length. So here, our predictor or our independent variable is height category. Okay, in this case, we're using height to predict thumb length. So what is our predictor variable or independent that we're using to predict something else? Height. In this case, our independent variable is in inches. So the difference here is the IV was categories, short and tall. And here we have the IV is continuous. It's a number representing how tall they are. Okay, in this case, what is the dependent variable? Also sometimes called the response variable or the outcome variable. So what is the thing that we are trying to predict or that we're trying to measure at the end of the day? In this case, well, we're using height category to predict what? To predict thumb length. And in this case, we are using height to predict, again, thumb length. So hopefully y'all are with me so far. Okay, so thinking back to this simple model, right? So this is the case where we're using short versus tall to predict thumb length. And if you remember, we had like the short group had their model and the tall group had their model, and we drew in the center and the spread. So how did we characterize the center on these models that we drew for the short and the tall groups? That center was the mean. In our simple model, where we have our shape, our center, and our spread, how did we characterize the spread around the center? Well, we learned that the way that we characterize that is by using the standard deviation. So that represents the average amount of spread that we see around this center, around the mean. On average, how spread out are our data points? And the models that we built from this were very simple. Something like the dependent variable is equal to the mean plus some error, and we would use standard deviation maybe as a way to judge this error, right? Plus or minus, because it can be above or below. So in this case, our dependent variable, we would plug in thumb length equal to some mean plus error. But we actually added, if you, can't remember if it's, we came up with something along these lines when we built these simple models, right? So originally we had the two separate models, which was just mean plus or minus error, mean plus or minus error. But then we were able to kind of shove them together into this one combined version where, okay, we'll start with the low version for the short half of the class. And then if we know that they're in the tall half of the class, we'll add 6 to bring them up to this part of the model. Right, so this middle portion, we can sort of think of as we added in here to our model the effect of height category. Right, meaning that if they were short, we didn't alter it at all. But if they were tall, then we added 6. Okay, so this hopefully seemed like review. This is where we're moving into with classwork 10. So again, we're still using 2 variables. We're still using height as our independent variable to predict thumb length. But how we characterize the center, the spread, and the model is a little bit different because this is now a continuous variable. So how do we characterize the center? Now, hopefully this doesn't trigger flashbacks from algebra, but when we're working with 2 continuous variables, then we're not going to split it into groups like this. We're going to be looking at them as one continuous variable plotted against the other. So in other words, we're going to be looking at scatter plots for our models, right? So the shape would have to do with the scatter plot itself. The center is going to be the regression line that balances the errors above with the errors below. We'll have more on that in classwork 10. Now the equation for this regression line, which again is going to connect back in classwork 10, we have y equals b naught plus b sub 1 x. And this looks very algebra-y, but we will talk about what each of these things stands for. Okay. So keep in mind, this is the equation for a line that works as the balancing point, balancing all the errors of all these different points. So we also characterize spread differently when we're talking about continuous versus continuous variable. So now we're talking about spread. We still are talking about spread around the center, around this line. We're talking about how spread out are all these data points from this line. Right? If they're really, really close to the line, that means that there's not very much spread. It's very tight together. If they're really spread out very far from the line, that means that there's a lot of spread, that it's a weak correlation. So in this case, when we talk about that spread, we're really talking about correlation. How well correlated are these data points? How liney are they? Right? So if we've got this, if we have one that has low spread, we would see the dots close to the line. If there's one with a lot of spread, then we'll see those dots really far from the line. So this is what I mean by spread. How spread out from this line are these data points? Okay, so that's correlation. Now our model we've been using, so we're going to use this modelese, dependent variable equal to, sorry my dogs, constant plus effect of the independent variable plus error. So we've been using this, right? That was part of what we were doing in this classwork. We're saying dv equals the effect of the IV plus error. If you remember back to our reading, it also mentioned this constant, right? And so this constant we're going to put back in here. Now I'm just going to connect this model effect of IV. Okay. So here, this model is very much related to this regression line equation. So we'll go more into it in classwork 10, but here the dv is the y in the equation. So the dependent variable in the equation, we just refer to it as y, and it goes on the y or vertical up and down axis. Then we have equals some constant. This constant is this, the b naught, or b sub 0. So this is going to be a number. In our equation that tells us that constant, and we'll talk more about what exactly that means in the next classwork. Then we have plus b sub 1. This is going to be our slope, and this really is the effect of part. This slope represents what effect does the IV have on the dv, or what effect does x have on y. Okay, so this x, that's our independent variable. Y is dependent, x is independent, and again this b sub 1, that's going to be some number or value also that tells us when x changes, if something happens and we change our independent variable, how much is our dependent variable, how much do we predict that's going to change? That's what this number is going to tell us. Okay, so a little quick introduction, wrapping up this classwork. Let me go ahead and show a little further. So if you have any questions for me, go ahead and let me know, and classwork 10 will continue to build on this, and so hopefully it will become more clear.